Hello, everyone. Welcome back to our next session of the 2024 EA Global Summit. I'm Ryan Schmier from Spark Services North America. And for this session, I'm joined by Chris Armstrong, President and Chief Architect of Armstrong Process Group, who will be talking to us about API modeling in Sparx. Items as we get going, perhaps. If you have questions, you can either put them in the question and answer session or section within the GoTo platform, or you can put them in the Slack channel. If we have time, we'll get to as many questions as we can live on the session. Anything that we don't address live, we will be following up with on the Slack channel itself. If you're not yet a member of the Slack channel, we'll be posting the link shortly. So with that, let me hand this over to Chris and for a demo.
All right, thanks very much. All right, so I just have one slide, which is this slide, just to introduce the topic, modeling APIs with Sparx Enterprise Architect, but I'm going to pretty much do everything live. So I'm going to flip over to Enterprise Architect. All right, and just to confirm, since I can't see the GoToWebinar screen, everybody can see this, Ryan?
Yes, Chris, we can see it. Can I suggest you turn off your camera so you get a little bit more bandwidth?
Sure, just 1 second. All right, a little better?
You're good
All
to
right, well,
go.
let's get going. And so also, since I'm not looking at the GoToWebinar window, Ryan, don't hesitate to prod me if I'm running out of time. I'll try to look at my cell phone clock here. All right, so we're going to basically cover a couple of topics, starting with how can you represent APIs in Enterprise Architect. So we'll take a look at a simple example of an API that actually came from a Swagger 2.0 file. Take a look at what those models look like, what they're trying to describe, and then how we can use those models both from a provider perspective and a consumer perspective. Namely, it's one thing to specify what the interface is. Of course, Swagger and OpenAPI is a common way to do that today. But then once we've specified the API, we need to then represent the design of the implementation of that API by some software component. And then we also need to show, theoretically, because otherwise why are we building it in the first place, how that API is being used by a consumer application. And then I'll show you a couple ways that we can represent some high-level data flows using APIs as well. And then take a look at some examples predominantly in telecommunications, particularly from the TM forum, which as some may know, has a family of about 90 well-specified open APIs that represent common functionality required for business support systems and operational support systems in the telecommunications business. And this is where I'll provide some visibility into how we can reverse engineer both JSON schemas and then theoretically YAML as well, and OpenAPI Swagger files. So let's start off by taking kind of the big picture of what are some of the different elements of an API that we need to consider about modeling and what they might look like. So what we've got here is what we call an application definition diagram. So this is a part of the REST 2.0 MDG technology that we've created. From the 2.0, you should accurately derive that this is based on OpenAPI 2.0. Of course, a lot of people have moved on to OpenAPI 3.0, which is something that we're working on enhancing, both from an MDG perspective as well as importing those OpenAPI spec files. But there's also a new one that's been, well, perhaps not as new as it used to be, but a newer one that tends to try to cast a broader set of interaction scenarios and integration scenarios called async API, which can model not just REST APIs, but a lot of other different flavors of APIs that are of particular interest to people that are implementing event-driven architectures and microservices. So we'll stick with, but for the most part, the general idea is going to be pretty similar with all those different variations. So what we have here in the application definition diagram is we have a REST application. This is actually a representation of the original Swagger file itself. It's got a couple of simple base properties like base path, the host, the Swagger version, for example. And then, as many may know, a big part, a Swagger file or OpenAPI file is trying to really represent two major things. Of course, OpenAPI 3 and async, add some additional concerns, but ultimately, what are the different paths or endpoints on which HTTP methods are available? And so we're calling those REST path items. And then what data is required as both input data as well as output data with a set of definitions. And of course, OpenAPI doesn't demand that you do this any particular way from an architectural kind of perspective, but there's one way to do it, which is basically you specify all of the data that an API needs inside the API. And that's, all well and good, makes it nicely, self-sufficient and can stand alone. But when you have a family of APIs that share common data, a best practice, of course, is to base that on some kind of canonical data model that might be expressed as a set of JSON schemas or YAML files. And so, of course, when you're specifying the Swagger files, you've got an option of whether to, again, reference internally defined data definitions or externally defined. And we can handle, both of those kinds of scenarios. We also have some simple relationships, namely a stereotyped realization called implements that basically is showing that the concept of this Swagger file, offers up these different paths, endpoints. And then optionally, we actually find a lot of people don't model this, but you can if you'd like to, is the ability to specify path relationships, which is a stereotyped nesting relationship that represents how you get from one path to another based on the URI. So to get to this path item, we traverse the slash accounts path and then get to the brand path item, aka a resource, the R in REST. You would then put this as you would append this to the preceding concatenated path. So slash accounts, slash brand, slash curly brace brand ID, so on and so forth. So like I said, it's important to have the implements relationship, particularly for some other modeling that we'll get to a little bit later. The path, perhaps not quite as much. And actually, as you'll see, a different approach towards this is that we don't specify these path items really just as individual resources, but that actually becomes the full path, which would include that concatenation. So again, this is supposed to identify, all of, those endpoints, but to get down to a lower level, namely, what are the methods, the associated schemas related to the data definitions and other things, we can do that at a lower level of detail. And so here we've got more information about one of those, again, the top level accounts path item. And as many know, the whole idea behind this is that, we generally want these paths to be have names that are based on nouns, aka resources, data objects, or data concepts. It is generally not a best practice that we should be using verbs in the names of the past. But again, Swagger and EA for that matter doesn't really care. But the whole point of that approach is that you specify the behaviors as a set of operations on that path item, and you are constrained on each individual endpoint to the HTTP methods. And so here we've got the HTTP get method and the HTTP post method. In this particular case, this was actually put together based on some client work, actually many years ago. One of their practices is to explicitly specify that they had not implemented certain methods, but most people these days are just going to do it by absence. So namely, the only methods that this endpoint supports are the ones that are explicitly specified. But the idea is that we can specify, again, the different stereotypes for these different operations is a part of the REST API 2.0 MDG technology. But the constraint, as everyone may know, is that you can only have one of these per path item. There can only be one get, one post, one put, one delete. If you need more than one, then you've got to put that on a different endpoint. And of course, the operations will have the parameters, their data types, and return types as well. And then just to provide context, as people may know, since we're modeling these REST definitions as separate elements in the repository, so here's the create account request. Here's the account list response, which is really a collection class of multiple accounts. With the references keyword that comes from the references keyword in the Swagger file. You'll notice that both of these guys over here have some behaviors, which of course they really don't in the Swagger file. So those are constructs that are added to support some of the modeling that I'll show you in just a little bit. But of course, another common thing is not just to show relationships amongst the definitions, but also relationships to different enumerations, which are of course very common. So here we can see the different literal values for activation mode, API type, or language. And then just because we're, again, trying to provide context, in this case, again, showing the child path items based on the continuation of the endpoint URI. Now, one of the things I'm not going to demonstrate it just because of time and scope, but one of the nice features out of the box of Enterprise Architect is the ability to generate schemas from classes in your EA model. And the out-of-the-box schema composer really doesn't care about stereotypes for the most part, so they can be just plain old classes, or they can be decorated with the REST definition and REST property stereotypes. But just to give you an example, this is what a JSON schema file generated from the account data definition might look like out of Enterprise Architect. All right, then let's talk a little bit about the whole point of creating this spec is to have it represent a contract that a implementer of the interface must conform to in order to be considered possibly conformant. Of course, as many people know, it is not necessarily sufficient to have implementations of those methods, but we also need to have, or at least it's a good idea to have some kind of conformance tests. And so the idea with that is, not only do we need a Swagger file, but we should have, maybe a Postman collection so that we can easily do some unit testing, by the developer, and then have an automated set of unit test cases that can be run automatically to verify that not only have you implemented all of the methods of the API, but that they are accepting all the correct parameter types and returning a structurally conformant response. But now let's again take a look at how we might use this to represent the implementation of this API. So this is an interaction overview diagram. It's one of the UML diagrams that doesn't get used a lot, but it is pretty convenient, I've found, when you want to basically demonstrate that there's a bunch of interactions. That's why it's called an interaction overview, aka sequence diagrams. And you kind of want to weave them together to tell an overall higher level story. So this is basically saying get account list has a basic flow. And then depending on what happens inside of that, there might be no accounts, there might be a invalid operator code, or there might be some kind of a database error. I haven't elaborated all those, as is not uncommon. I just did the basic flow. And the nice thing, of course, about being able to do this, and we'll see a little bit more about the outside of the component in just a little bit. But basically, we've got some sort of microservice that we're going to create to implement this API. In this case, it's the account management microservice. And maybe we'll just take a quick peek over here at the corresponding class diagram. So basically, this is a piece of software that we're going to build. We're using just a plain old UML realization relationship to show that we're agreeing to implement all of the methods of the accounts endpoint, and that based on the data that it uses, we have dependencies on some other entities, as well as a security subsystem that's helping with some authentication and authorization. So pretty simple, I think, hopefully from a sequence diagram perspective. So the whole idea is that some consumer application, again, it's anonymous. We really don't care what it is. So we're just representing it as an instance of an actor here, is invoking the get account list method. And as many may know, when we create a realization between a classifier like a component or a class to a interface, because as you might guess, this REST path item is a stereotyped UML interface element. One of the benefits that comes from that is that when you select a message on the sequence diagram, you can select from all of the methods that are defined on all of the interfaces that it's agreeing to implement. So this is, again, a feature of the modeling language, but also a really nice feature of Enterprise Architect. So if you've got all this stuff defined, you can easily select and reuse that content when you're building your sequence diagrams. And because it's actually bound to these operations in the model, if you should change the name of those operations in the Swagger file or in the design of the API, those method names will automatically get updated in any sequence diagrams that use them. So here we're just going to go ahead and validate the credentials, with the security subsystem, just to provide some context. But then we're going to go to the internal data provider, which again, we're not getting into details about, is this relational, non-relational, whatever. But we're asking it to, get the account list that we end up creating the account list response REST definition object. And then based on, how many accounts come back from that get account list, we loop through it. And then basically, get the account from the list, get the data from the account data object, create a new REST definition or a new data structure that's conformant to the REST definition. Because again, this account here might be the native representation of it in the data store, for example, or depending on what programming language might be used. But here we're, again, creating a new account definition and then, setting the values of its properties, adding that to the collection, and then we get back a response. So again, pretty simple implementation of a pretty simple function, but again, one side of the equation after we've specified what that interface is supposed to respond to. Then go take a look at how we might reference this from a consumer perspective. And this is, again, pretty simple, generic example. So here we've got the same account. We've got the account management interface, the REST application. This is not the microservice, because the whole idea is that the consumer doesn't care who the implementer is. As long as the implementer conforms with all of the operations of the interfaces, then it's going to be able to expect a response when it sends a message for it to do something. So, again, based on the preceding diagram, it's the account microservice or account management microservices that's doing that, but the consumer, again, doesn't care. So we're basically showing that the consumer is dependent upon or uses that same set of that same endpoint and the two methods, and it also being a component, implements its own interface that does some things and some other things. And again, the usage of this API is pretty simple. So here we're basically just showing that we're, getting the account list. And again, if we wanted to, we could put a little note here or a hyperlink, to go look at the provider sequence diagram. But again, while it's often interesting to know what happens when you send an API request to some other component, kind of again the whole idea of encapsulation and whatnot is that you don't care. You're just expecting the sort of response. So this is should be good enough. But again, there's those additional diagrams available if you wanted to get into it. And again, just like we saw before, because the account management microservices implements those methods on the APIs, we can again select all of those methods from the drop-down messages property. All right. And then a couple of tips about some other ways to model this. So can we focus so far on, what's the structure of the path items in the Swagger file, and the data definitions in the Swagger file, their properties. So again, those are pretty much design time structural diagrams. And then we showed a provider diagram, predominantly focusing on messages, i.e. interactions and sequence diagrams. We also might want to level it up a little bit because, particularly the last couple are pretty detailed sort of things. So what we can do, and again, I'm going to offer just a couple of different options depending on what you're trying to do, and being able to take advantage of particular features that Enterprise Architect implements pretty nicely. So one way that you can do this is you can specify using an information flow. So this is a built-in UML 2.5 relationship that's very, very powerful. And as some may know, its real power is that while it looks just like a dependency, right, a dashed line with an open arrowhead, because of the semantics of an information flow in UML, you can associate classifiers with the information flow. So when you create it from scratch, it will pop up this window by default. And what it's really asking you to do here is, add an possibly existing information item to be associated with this relationship. And you can press add, automatically it goes out and again finds all classifiers. And we typically would, again, use some kind of data object for that. But, EA and UML really don't care. But of course, another option is you can create a new one on the fly. Again, if you've got the interface definition, the Swagger file already into your repository, you should have all that information, available. But then when you pick it, it brings that back here. And of course, if I want to change it, I can remove it. You can add multiple information items to a single information flow. And then that ends up putting, this label next to the information flow. But you'll notice that when we select the relationship, the name of this connector is not create account request. That's the name of the information item that's associated with it. So again, it's a really great way to specify, again, the source and the target of information, and then explicitly what information is on that flow. And of course, as many may know, all of this information is being stored in the EA repository, and you can actually create a report that shows you, that could show you all information concepts of whatever kind of flavors they might be that are being transmitted between two classifiers throughout the entirety of your repository, or you might want to filter it to a subset of your repository. And then you can also often we'll see people putting tagged values on some of those information items, in many cases that have to do with information security, such as this, is this PCI data, PII data, HIPAA data, so on and so forth, so that you could actually support some of your InfoSec, regulatory reports with data directly out of the repository. Of course, this is keeping it at a pretty high level, so just between the components. The information flow doesn't really have any semantics about how this happens, so we don't know if component 1 is sending it to component 2 or if component 2 is asking for it. But the thing we're trying to do, at least at a high level of architecture, is show where the data is coming from and where it's going to, not how it's transported and what mechanisms being used. Because again, as you may know, there's a lot of different ways to implement that. In this case, wanted to keep it pretty high level, but you could make it a little bit more explicit. So for example, you could put a port on these components, and then on the port specify provided interfaces, where you could actually make it really explicit that this create account request is coming from a component 1 that's implementing the accounts endpoint in the Swagger file as a provided interface, and that it's being used by the consumer, the required interface on the other side of the port. Another way to do it, though, depending on what you're trying to get out of it, or you could do it both ways, although that does bring up the possibility of some inconsistency, is explicitly putting the data object on the diagram and then creating trace relationships. Just to keep it simple, you might choose to use something a little bit more semantically specific if that's necessary. But basically showing, that ultimately, the create account request is an output of component 1 and an input into component 2. And one of the advantages of this, although you may not actually put this on a diagram, is then we could create a CRUD matrix using an EA relationship matrix to show the traceability of data objects between applications or components. So this one is going to turn out to be, pretty simple. But basically, this is just like any other relationship matrix you might create in Enterprise Architect. Select a source portion of the model and type and a target as well. In this case, we're using a trace relationship, but you can specify, again, an out-of-the-box what's called an overlay, EA extended : CRUD, which is basically a tagged value that has some enumerated values, namely C, R, U, and D. And the cool thing about an overlay, as some of you may know in the matrix, is that you can do more than just say there is a relationship. And when you do that, of course, you see an arrow pointing, to the left or pointing up, or possibly both ways if you've got the direction set to bidirectional. But with an overlay, you can actually put in metadata about the relationship. And so using the extended CRUD tagged value allows you to put a C, R, U, and or a D in the relationship. So this is basically trying to show that component 1 create, reads, and updates the account response, and component 2 creates the any URI response. Again, obviously not all that interesting because we only have 2 things, but if you've got a lot of components, a lot of data objects, and again, creating a application to data CRUD matrix is not an uncommon thing in many architecture practices. All right, so that's kind of the big picture on modeling, the different ways we can model interfaces themselves, the things that implement those interfaces, and then things that use those interfaces. Now we'll transition into some other examples where the content was actually reverse engineered from existing Swagger and JSON schema files. And we're going to go take a look at the telecommunication examples. So where this is all coming from, and again, this is in particular for the TM forum, there is, and again, I'm keeping it pretty simple for this example, but here we've got a Swagger file. So this is OpenAPI 2.0. And perhaps I should have shown this earlier for people that might not have been familiar with like what the heck I was even talking about with Swagger and Open APIs. But this is a Swagger file. And OpenAPI 3 and Async API are very similar in spirit. There's just some different sections. But again, the main two sections are these. In addition to some kind of overview content about the API as a whole, we're basically trying to say these are the endpoints. So service slash service,
Chris?
ID. Yep. Yep. Can you hear me?
Interrupt, but okay, the screen was just now we can see your Swagger file. Your screen wasn't refreshing very quickly.
Okay. All right. Sorry about that. We must be having some perhaps bandwidth problems here at the hotel we're at. So here we've got again the path, the endpoints, and then within a particular path, we can have the different methods. So here's a get method and a post method, and then there's all sorts of other information about the parameters and the responses and all that kind of stuff, as well as again the data definitions for the data that's either coming in as one of its parameters or the data that's going out as a part of its return values. And then again, optionally, it's not required by OpenAPI spec, but it's not uncommon, again, when we have a lot of APIs that share common data, to basically have a set of JSON schemas for the data itself. So for example, this is the canonical definition of a service from a telecommunications perspective, all of its properties, their data types, including any references they may have to other data types that presumably are within this set of schemas. And so, it turns out the TM forum has, again, a huge depth of content. There's 9 different domains. So this is one, the service domain, but there's a marketing sales domain, a customer domain, a product domain. And again, we're just showing a single API where there's like 90 more of them. But what we're able to do is, let's go take a look at this in the repository, is in order to support reverse engineering, and again, reverse engineering is done by another MDG technology add-in, so it is not a part of the REST API MDG technology, because that is simply, as many may know, a UML profile that identifies new stereotypes and tags, as well as new diagram types and other sorts of things. So the API management add-in that we've created uses or expects the REST API MDG to be available, because that's, that describes the data structure of how all this data gets transformed from the text files into models. But one of the things that's important to do is that we need to mark a portion of our model as a namespace. And that's what we're showing here with these two things. And because theoretically, you could be using lots of APIs from a lot of different places, ones that you've created, ones that your partners have created, ones that have been created by industry trade groups like the TM Forum that are supposed to be common across your industry. And it's important to specify, again, namespaces. And so there are 2 stereotypes basically available for that. Oh, wrong button. Basically, we can mark one package as an API namespace. Namely, this is where we expect the OpenAPI files to get reverse engineered into based on the base path of the what's in the Swagger file. So it, again, groups them appropriately. And then we have the same kind of stereotype for schemas. And that's what we're showing, down here. So in this particular case, and I'm not going to show the reverse engineering just because it takes a little time, not a lot. Plus, to be quite honest, I've had some issues with my machine behaving itself, and didn't want to take the risk. But believe me, and be happy to again show anybody a live demo of the reverse engineering. If you're interested, just let us know. So basically, I've got two versions of this API. So I've got, the 3.0.0 version, and there, of course, was earlier a 1.0 and a 2.0 version, and the 4.0 version. So most of the open APIs at the TM forum, the modern versions are really considered 4.0 as of a couple years ago, and then now, there's a push to bring them up to the next level of maturity and features with 5.0, and that's where the TM forum's actually also introducing async API representations of the same functionality. And in this case, we're reverse engineering, a couple of additional properties. But then if we go, inside of one of them, so let's go take a look at 4.0. There are a lot of paths and there are a lot of definitions. So let's start with the paths. So keep in mind, again, the paths are really the endpoints associated with the resources. So here are the paths for the /service path item. And we've got a post method, create service, and we have a list service get method. We also have details about all this stuff. So as many may know, there's no shortage of things you can specify here. So we've got not just the name, but we've also got the description of this, and then some of the other metadata that's in the Swagger file, like the operation ID, its different responses. And so some of the stuff we decided to keep in its original JSON or YAML, just because trying to recreate a UML model of every single little property in the source file just doesn't make a lot of sense, in my opinion. Certainly willing to argue about it with somebody. And then, the ability to specify, the parameters, and there, if there's any documentation associated with that in the Swagger file, as well as the direction of those parameters. And then for the data definitions, again, this is, obviously a pretty complex API because there's about 50 data definitions here. So if we go take a look at one of them, like a service, again, it's the same kind of thing here. We've got some metadata properties about the definition itself that could come from the Swagger file, and then the same kind of information about the individual properties. And let me open up that real quick. So the same sort of thing that we saw for the operations. And then one of the features of the API management add-in that does this import is that there's a flag that you can set that can specify when you're importing the Swagger file and its associated REST definitions, do you want me to see if there are corresponding schema definitions for that local definition? So this here, the REST definition service, is a part of this API. So it's part of the definitions of service activation and configuration. And it's got, again, all of these properties, including relationships to other things. So, of course, one of the cool things about one of the consequences of reverse engineering both the APIs and the schemas is that any reference keywords to other things get imported as actual relationships, and so we can reconstruct those things as graphical models. But what it's trying to do here is basically show that the local definition of a service, and it's pretty simple logic. It basically goes and asks you to specify what is the parent namespace for schemas, and it will do a lookup to try to find a schema that has the same name as the definition and automatically create a dependency. And this represents actually kind of an evolution within the TM forum. And some of you folks may have realized the same thing in the work that you're doing, which is a lot of times you'll start off doing this stuff again pretty locally, a project at a time, create an API for a particular consumer. You know, in the back of your head, you've got this notion that we've got to, share common data, but nobody's really taking responsibility for it. It's not a huge priority. But then after a while, you get 10, 20, 30 APIs, and now you've got this data management issue where a lot of different APIs have specified the same data in different ways. You know, the names of the definitions could be different, although that tends to be less likely. But the number of properties they have, the names of the properties, the data types, all that kind of funky stuff. So this gives us the ability that if we do have a canonical, a set of schemas, that when we import all of our Swagger files, it would basically show all APIs that have a local definition of a service, but you'd be able to see them all traced from the same canonical schema element. And then from an API governance perspective, you could then go say, hey, how conformant is the local definition of a service to the canonical definition of the service? And let's put together a plan to start making them more conformant. And sometimes that might be moving or adding to the canonical definition, because you might find some definition in an API has additional data that you didn't think of. So you could copy it over here, make changes, so on and so forth. But you may then eventually decide that even though it does increase complexity a little bit, that you don't want to use any internal specification of data definition in your Swagger file, and basically have a practice that says any data that's shared. So maybe that might be an exception for some local data, but any data that's shared, we really want to reference the canonical schemas, that come out of our canonical data model. Okay, so I think that is about it. So we got about 8 minutes left, right, Ryan? So hopefully that's a good start. And I don't know if there's any questions. Happy to take some, or can answer them later offline.
Yeah, we actually have a few questions. The first question is, provide this EA project for us to have as an.
I couldn't quite hear you all, Ryan, so hopefully there weren't similar audio problems when I was talking, but I think you asked, could we get access to this model for review? And the answer is yes.
Yes. The next question is, where can I get the REST 2.0 MDG and API management?
So I'm pretty sure, and I forgot to be as prepared as I could have been, or actually just even putting it on this landing page here. Maybe I'll do that before we share the model. It's up on our website someplace. I just don't remember what the URL is. But the MDG technology can be downloaded. And actually, now that I'm thinking about it, I think the MDG technology, what the download includes, the sample model we're looking at. I'll double check that. So you may be able to get the sample model and the MDG technology all from our website, or you can send us an email. And the MDG, the API management add-in, that is not something that is generally downloadable, because it's got some nuances and whatnot. It's something that we typically offer up as a part of a consulting engagement to help people with API management and API governance. Of course, we certainly might be willing to make some exceptions. So, feel free to ask any question, send me an email. that I can provide should be probably in my bio or something, and I'd be happy to set up a call with you to talk more about that.
Great. So that's the last question. If there are any more, we will address them in Slack. Thank you again, Chris. And we look forward to the next session, which is focused on the JAMA integration. And it'll be Nizam Mohammed and Harry Brezhik from JAMA, who will be co-presenting the next. So thank you all for joining, and we'll see you on the next EA Global Summit session.
All right. Thanks, everybody.